In this example, I'm going to be using the empirical rule. And so it says that this internet service has user connection times that are normally distributed with a mean of 5 seconds and a standard deviation of 1.5 seconds. And so if I were to use this picture right here to draw out a normal curve for my given problem, I'm going to have something that looks like this, where 5 is the center of my curve because that's my mean, and then mu plus sigma, so one standard deviation away from the mean, would be 6.5. Going in the other direction, one standard deviation away from the mean would be 3.5. If I were to keep going, so if I do 2 standard deviations within the mean, then I'm going to either add 3 to 5 or add 1.5 to 6.5. But either way, I'm going to get 8 right here. And if I go the other way, 2 standard deviations the other way from 5, I'm getting a value of 2. 3 standard deviations away, I have 0.5. And then here, I have 9.5. And so if I compare the curve I just drew with the curve up here, this would be mu plus or minus 1 standard deviation. From 2 to 8 would be plus or minus 2 standard deviations. And then from 0.5 all the way to 9.5, this would be 3 standard deviations from the mean. And so here, you can see that these percentages are still going to be the same regardless of the numbers that I have here. So within 1 standard deviation of the mean, I have 68% of my data. And this is not a good curve. It's not symmetric, but that's okay. The percentage is still going to be true, right? And so here, part A is just asking what information can we gather from this statement. Basically, what I meant by this was, can you use the empirical rule? And so since the connection times are normally distributed, we can use the empirical rule. So if I move on to part B, what is the probability that a connection selected at random takes, so the first part of part B is from 5 to 6.5 seconds. So if I convert this into probability notation, I'm looking for the probability that x is between 5 and 6.5. And so what I can do here is I can just go back up and look. So I didn't copy the percentages down onto this picture. But if I go back up and I look at this chart, this would be 5, this would be 6.5, and so I see that the area, or the probability, is 34%. So here, the probability that a connection time selected at random takes from 5 to 6.5 seconds is 34%. If I look at the second part of this part, then when I convert this to probability notation, I'm now looking to see the probability that x is between 2 and 5. And so if I go back up and I look, this was 3.5 mu minus sigma, here was 2. And so what I'm going to do now is I'm going to take these percentages and I'm going to add them together, because I now want from 2 to 5. And so I have 13.5 plus 34. And that will give you 47.5%. In this example, we're given a normal distribution with a mean of 35 and a standard deviation of 8. And so if I were to draw that out on a number line, pretending that there's a normal curve on top of this line, then the center is going to be 35, which is the mean. And then within 1 standard deviation, I'm going to have 35 plus 8, which is 43, and 35 minus 8, which is 27. Moving on to part B, it asks what percentage of the wheat yields are fewer than 43 bushels per acre. So converting this to probability notation, I get x is less than 43. And so here what I'm going to do is I've taken the percentages and I've written them here. You can also just go back to the graph. But what we do to find the probability that x is less than 43 is you're going to start at x is 43, and then you're going to add up all of the percentages that are for values less than 43. And so here, when you add all of those up, you get 84%. In part C, it asks what is the probability that it is between 11 and 27. So writing this out in probability notation, I have that x is between 11 and 27. And so what I'm going to do here is I'm going to add up all the probabilities starting at 11 all the way until 27. So not including this 0.15 and not including this 34. And so when I add these together, so this is 2.35% plus 13.5%. When you add those together, you get 15.85%. Part D is asking about the probability that it's between 51 and 59. And so here, we don't actually have to add up any probabilities because 51 and 59 are right next to each other. And so I see that the probability is just 2.35%.